So, in our last meeting, we went through the course syllabus and the topics that we want to cover in this course. Today, we're going to go over chapter 1, which is an introduction to this kind of course and this kind of analytics. So, you guys know that we have three types of data analysis. We got descriptive, we have predictive, and we have descriptive. Do you guys remember the definition of descriptive analytics?
It's like used to describe what the data's telling you, like just basics, like things like age or name or something like that.
Exactly. This kind of statistical analytics is used to describe the current situation that we are in, the current data, and provides a kind of description of the data set that we have in hand. Predictive, we try to analyze our current data along with historical data to get a sense of what may happen in the future. We try to predict the future. For example, we analyze stock market data between the year 2000 and 2019 to be able to predict stock market trend in like 2021. For example, Dow Jones Industrial Average, it goes up or down, for example, in a certain time period. Prescriptive analytics is used when we want to optimize something and we want to maximize and minimize something. We already discussed this stuff, like optimization, simulation. And simulation is used when we have uncertainty in our data. Okay? For example, in prescriptive, we have two categories, optimization and we have simulation. Okay. In optimization, we have three types of variables: objective, which has to be optimized, whether maximized or minimized, depending on the type of your objective. For example, as you know, we have revenue minus cost equals benefit. We want to maximize revenue, benefit, or minimize cost. Okay? One of these variables or combination of these variables can be used as our objective variable. Okay? We have constraints. Our model must meet the requirements defined by the constraints, and we have also some input variables. These are the three important variables in optimization. Simulation is like optimization, but there is uncertainty in one or more input variables. Some of our input variables are unknown. In simulation, for example, like optimization, we have x1 to xn, and y is our output variable, or objective variable, or our outcome of the model. One of these input variables, x1, x2, or 3, they're unknown, and we try to simulate these variables with probability distribution. So these two types of analysis, data analytic methods, fit into this category, prescriptive analytics. Let me make sure it is recording our session. Okay. So, yeah.
What's the last one underneath the
simulation?
No, under constraints.
Constraints, input variables.
Okay.
Sorry about my terrible handwriting. So in this course, in chapter 1, 2, 3, we cover some about descriptive analytics. We learn different type of data, what kind of methods can be applied on those type of data, categorical, numerical. We're not going to discuss predictive, and then in chapter 13, we will cover optimization and simulation. That's all about this course. So now, let's talk about some jargons. We have data, information, and knowledge. Knowledge. Do you guys see any difference between these three terms?
Well, isn't like information is obtained after?
No, I mean in general, not in data analytics. So in generally speaking, they are used interchangeably. Data, information, knowledge, most of the time. Yeah, oftentimes. But in data analytics, they have their own specific meaning. Data refers to anything that has not been processed, unprocessed data, unprocessed material or something. Whatever we have in hand is called data. Like name, number, price, cost, and etc. Okay? So any unprocessed information or anything is called data. When we process our data, it is going to be information. And when we find some kind of recurring patterns, trends or patterns in our information, it will be called knowledge. For example, data. Like retail stores, they collect their point of sale data, like cost of something, price, their customers' information data, and their products or information. We put them in a table or a number of tables called database. This is table 1, table 2. For example, this table can be used to store information regarding the products. This is for customers. Okay. This is one table that holds information for products. This is the other table holds information for customers. Collection of these two tables along with other tables is called database. Okay. So we hold our data in tables and they're all put into one or more databases. But once our data is processed, when they go through data analytics methods, like what we learned here, it will be information. And we hold our information in information bases. Okay? So it must be processed. Okay? When we process our information base, we get knowledge base. The information or data, whatever that is located inside the information base, can help decision makers. This is used by policymakers, strategists, those who make set a strategy for a business or whatever. So our job as a data analyst is to process data located inside databases and then get information bases. And in the highest level, we can process information bases and provide some knowledge to decision makers. Knowledge, for example, at Walmart, if, for example, customer above 30 years old, if they buy product X, it is, for example, 80% likely to buy product X2. This is a kind of information and knowledge. This kind of knowledge can help policymakers. For example, we buy cheese puff, eat some kind of creams and etc. Okay, so they decide to put them in one shelf, okay, to improve their sale. This is one simple example for knowledge and information base. So we need to process raw data to get information, something like this, and provide it to decision makers. Is there any questions so far? So we are living in the age of technology and data. Our job is to get this information and process them to fetch knowledge out of data sets and information bases. Information is collected through sensors. We have some kind of new technology called wireless sensor network. Through those sensors, tons of data, even petabyte and zettabyte of data can be collected in less than a second. We have kilo, mega, giga, tera, peta. I guess zetta is 10 to power 24. Bit of information, 10 to power 3, power 6, 9, 12, 15, and zettabyte of data. For example, physicians, they can monitor their patients through these kind of sensors and monitor their situation through these kind of sensors. And tons of data can be collected within a second. But, so data collection is not challenge. Challenge is how to process those huge information. So we need huge systems, powerful processors, and also we need powerful data analysis methods. How can we deal with this volume of data? Can we use traditional management model or traditional statistical methods to work with this volume of data? Of course not. So the next term is data analytics. Can I use this one? Yeah. So we have data analytics. Okay. This is a kind of new method designed to be able to work with huge data sets and fetch information from those data sets. It's not necessarily a new thing. It takes advantage of the models in management and also statistical methods and combine them with high-level programming languages. So data analytics can be divided into 3 branches. First is management, models, we have statistical, methods. Both these two tools or techniques have been in use for over 80 years. So data analytics is not necessarily a new thing. The novelty of data analytics is the use of high-level programming languages. Okay, so it takes advantage of these two tools and techniques, models that have been used over 80 years in management, and traditional statistics, and combine them with high-level programming languages. So combination of these tools and techniques is called data analytics. So for data analytics, we need to use machine learning algorithms that fall under this category, high-level programming languages. Machine learning algorithms. So we need a powerful computer to install these kind of machine learning algorithms. And these are divided into classification, prediction, and clustering. If you guys are interested in this kind of topics, you will need to take BA 345, I guess. Business analytics, introduction to business and data analytics. Classification, prediction, and clustering. With classification, our input variables are numeric and output is category form. In prediction, we have again numeric x's and we have numeric y. In clustering, we have number of x's and we try to divide them into different categories. Okay? So when we combine these methods with the traditional statistical methods and managerial models, it is going to be data analytics algorithm or method. Is there any questions so far? So data collection is not a challenge so far anymore, and we have access to large amount of data, and we should be able to work with these data sets. So one of the hottest topics in today's business world is called business analytics, also called data analytics. The use of data analytics in business is called business analytics. The term includes all the algorithms discussed in this book, not this course. In our course, we just cover some about descriptive and prescriptive. We are not going to cover anything about predictive analytics. And it is also the analysis of large data sets, which is also referred to as big data. So by using quantitative methods to uncover information, companies are able to gain competitive advantage. So as I said, we combine methods in statistics and management and combine them with machine learning algorithms. The three themes that I covered: data analysis, decision making, and uncertainty. These are all covered in this course. Now to install Risk, you need to download DTS Suite, which I uploaded in Chapter 1 module. You can install DTS Suite and you can get the keyword for this software from your textbook. And let's go to chapter 2. That was just an introduction to chapter 1 was just an introduction to data analytics.